giving you. Aisha is coming. You see, August 13, huh? This one, August 13. Can you see the screen now?
Yes, sir.
So August 13, I uploaded this and also the video in your messenger also I mentioned it. If you go through the messenger, messenger I'm opening. Look here in the messenger. Class 9 physics. August 13. We go back. Here. Here I give recording and homework are available in the link below. So this one I mentioned in, also I told you that try the MCQ part only from the attached file as much as possible. So how many of you tried, or how many of you have seen this? Anyone?
Sir, I have seen it, but
I don't remember. Sir, can you show me sir the homework?
I'm showing you, no problem.
11.45 sir, that was.
It's on, you see, classroom. I'm going to classroom. August 13. August 13, I uploaded it. And this link is given to your messenger. The recording. August 13, it was Thursday, right? Thursday class recording. And the attached file was there. And I told you to try the MCQ part. So why I'm reminding it? So that at least today you can start trying. Is it clear? Who did not try, you forget that one. At least from today you try as much as possible, because these ideas already you have, right? Condensation, melting, freezing, boiling. Then also you got this idea, huh? So molecular structure we are discussing, and also today we will discuss molecular movement. You will get more ideas, right? So last class we are discussing this one. Can you remember this? Till which part we did last class? Can anyone tell me?
I think 11.45 that. Oh,
Okay, this one we discussed, right?
oh no, sir, we have discussed this one.
We discussed this part, right? The second column, molecular structure, arrangement of particles. This part we discussed in last class. What we got in molecular structures? Can anyone recall? Hello? Hello? Aisha? Aisha?
Yes, sir.
Can you tell me the molecular structures of solids, liquids, and gases?
Okay, sir.
Molecular structure means arrangement of particles. Arrangement of particles, this column. Model of a solid we get here, and this description is available here. Then model of a liquid is here, and this description
So
we
only
are
these
getting it.
two,
Yeah,
only the arrangement of parts.
yeah. Model of a gas is here. Then we have the description here. In last class we discussed this column. Can you remember?
Yes, sir. Yes, sir.
Okay. And today we will discuss molecular movements, how the molecules are moving, hmm, how they
Yes,
are,
sir.
behaving inside the liquid, inside the solid, inside the gas, how the kinetic energy is involved. That one we are going to
When they are
discuss now.
heated.
Yes. So here we are going to discuss molecular movement, and this one is molecular structure. Is it clear to you?
Yes, sir.
Okay.
Yes, sir.
And sometimes in your structure questions, they are also saying you to draw the structure of solid, liquids, and gas in molecular format. That time you have to draw this way. Okay, the way it's shown
And
here.
right.
Yeah.
Okay.
Is it clear, everyone? Faiza?
Yes, sir.
Hello, Faiza. Are you getting everything? Then Nubrat was here. Nubrat, where is Nubrat? Nubrat, hello Nubrat.
Yes, sir.
Thank you for joining and read this molecular movement part. You will read. This one is for solid. Huh? When you start this one, you say solid. Huh? Molecular structure, molecular movement of solid. Then when you start this one, second one, you say molecular movement of liquid. Then this is third one. Okay, continue, Nubrat. 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 Hello, Nubrat. Oh, where is she?
Sir, should I read?
Wait. We can find another one.
Sir,
Yeah,
sir, is my voice coming clearly?
your voice is very clear, mashallah. I like your voice.
Thank you. Sir.
And
Thank you, sir.
here Ravi left again. Ravi is disconnected. Then
Maybe, sir, it was raining. It was
yeah,
raining.
yeah.
That's why there was some
Then
connection problem.
Faiza.
Yes.
Yes, yeah, you read then. This one, the way I told.
What's the page number?
This is page number. Here, page number is page number is 136, 135, then 134, 133, 132, 132. Okay, get it, huh? From there. Quick. Yeah, Faiza, start.
So, state of matter. Model of a solid. A range of particles closely packed together and
No, this
occupying
part is
given
over. This part is over. You read the third column.
space.
Second column is all the things are over. Third column is this one you'll read. Okay. Okay. Thank you.
Model of a gas.
Yeah, this one. Third column
Movement of
means
particles.
you should understand what is called column, what is called row. You see my cursor? Can you see my cursor? Are you seeing the cursor? So this cursor from up to down, this is called third column. Second column we are done. Second column is showing us molecular structure. That one is done. Now in third column, we are doing molecular movement. That one you will read for both, for all solid, liquid, and gases. Please continue. Vibrate
Solid.
about fixed
Vib-
positions.
one,
Yeah,
two.
yeah, read.
Solid, vibrable fixed positions, held together by the strong intermolecular bond between them. This explains solid have fixed volume and shape. Liquid, free to move about between clusters but confined within the vessel containing it due to attractive forces between them. This explains why liquid have fixed volume but take the shape of the vessels containing them. Gas, high speed, independent motion in random manner, negligible attractive forces between them. This explains why gases have neither fixed volume nor shape and are highly compressible.
Okay, very good. Thank you. Now look, in solid, they stay in their place. They vibrate, but they vibrate about a fixed positions. That means they move right and left from their place. Is it clear? And
Yes,
they
sir.
are held together by strong intermolecular forces. Strong intermolecular bonds is available between them. That's why solids, we know that solids have fixed volume and fixed shape. That's the reason. That's the reason because the strong intermolecular forces between them, and they are held together. And liquid, they move between clusters. That means the liquid molecules, they move in clusters. But gas molecules, they are moving independently. That means single gas molecules, they are moving, and they are moving in random manner. So you should be very much, you know, accurate during the description of this molecular movement. And gas molecules, they have very less attractive forces. That means negligible. Negligible means that is very small attractive forces um, between them. This explains why gases have neither fixed volume nor fixed shape and are highly compressible. In liquid, they have the attractive forces less than the solid, but more attractive forces than the gas. So this part is clear, all of you?
Sir, the last part I didn't get. Can you tell again?
Yeah. The last part means this part or the one I described about the.
No, sir. This part, the part that you discussed now.
Okay, just now I
Like,
discussed that
yeah.
liquid, they have less attractive force in comparison to solid.
Oh, yes, sir.
Okay, but they have more
Yes.
attractive force than the gases.
Uh, yes, sir.
Is it clear?
Gases, they have very less attractive force.
Yeah, uh, they have less attractive forces than the solid, and they can move in clusters. Okay, in
Yes.
vessel, within the vessel. That's why they have fixed volume, but they don't have fixed shape.
Uh,
So this much is done.
Yes, sir.
Molecular structure and molecular movement is done. Now we have some more learning outcomes here left. Look, we are done with these two, huh? A and B. And now
Yes,
we
sir.
will discuss CD. Describe the relationship between the motion of molecules and temperature. So now you tell me, I will take the answer from you. If temperature increases, what will happen to solid? What will happen to liquid, and what will happen to gas?
what, sir?
Yeah, if we increase the temperature,
Oh, what will happen? Oh,
if we increase the temperature of solid, if we increase the
yes.
temperature of liquid, and if we increase the temperature of gas, then what will happen to their movement or their structure?
They will slow
Sir,
down
Sir, the
the
and the
solids
solid
won't.
structure
will.
will.
Sir, the solids
The solid will
the
remain.
solids
The solid.
Tell
they
me,
remain the same, but their molecules will vibrate about their fixed positions,
okay,
and they
so
will vibrate faster as the heat
very good,
increases.
very good.
Liquids
That
will slow down and hence they will slowly turn into solid, I guess. And then
okay,
Liquid,
so
liquid.
liquid. Look,
liquid.
yeah, look, the two ideas are correct. Both the ideas came that one idea came from Sat, that he was saying that solid, if we increase the temperature of solid or if we give heat to solid, then what will happen? They are staying in fixed position, and that's why the way they were vibrating before, their vibration will be more, right? uh,
Yes,
so this is happening when we are not giving too much heat, like still the solid did not reach its melting point. Until then it will happen, isn't it?
yes, sir.
If it is reaching the melting point, that means temperature is too high, you are giving too much heat, then what will happen? If you are giving too much heat, then it will reach to melting point, then they will not stay anymore in their fixed position. Their intermolecular bonds will break down, and they will now behave like liquid molecules. You got the idea what I said? Hello?
Yes, sir.
And is it clear to everyone what I said? Hello? Other student,
Yes,
Hello.
sir.
Yes,
only
sir.
only one student saying yes sir. I want to hear yes sir from everyone. If you don't understand, then I should repeat. I will repeat it. Is it clear to you? All of you? At least you should write
Yes, sir.
yes. Write yes in your comment. Shafkat, if you can't talk, then you can also write. Okay, now if you are understanding this, then we can bring the same idea. Like if we increase the temperature, uh, we can also describe what will happen to liquid. From the attendees, Shafkat. Shafkat,
Yes, sir. Yes, sir. Yes. Sorry,
now,
sir. I was.
now, Shafkat, you tell me about liquid. What will happen? Just now we discussed about solid. What will happen to solid? Now, the similar
Solid
way,
or liquid?
yeah,
Oh,
uh,
solid.
yeah, solid we
Yeah.
already discussed. All right.
So now what?
What will happen to solid? Already we discussed if we increase the temperature. Now my question is, what will happen to liquid if we increase the temperature?
They will start turning into gas. Their particles will move apart, and they will spread randomly.
Okay, so you said one idea, another idea, until if it is not reaching the boiling point, then it will not be gas, right? So before boiling point, what will be the behavior of the liquid molecules?
So they'll move faster.
Yes,
Yes,
sir. Their
they
particles will start
they
breaking
the
down.
way
Their
they were moving, now by increasing the temperature, their movement will be faster than before, right? So very good.
Yes,
yes,
sir.
I wanted this one. Thank you so much. Now about the gas molecules. What will happen to gas
Yes.
molecules? if we increase the temperature, what will happen to the gas molecules? Gas molecules will still be gas, right? They will not
Yes,
turn
sir.
to
It will be
they will not turn to
anything.
any other thing, just they will be in gas. So here we are getting, again, kinetic energy is more, right? If we increase the
Yes, sir.
temperature. Now if we increase the temperature and the container is sealed,
Yes, sir.
then we will get one thing, and if the container is not sealed, we will get another thing. So I am writing both the conditions for gas. Here I am uh, writing the idea. Here we are writing gas. Okay, so gas, we are increasing the temperature, okay, for gas, and one condition is container is sealed
Or closed.
or closed. Very good, very good. Container is closed. Container, I'm using your word, is more easier to understand. Container closed. Okay, this way, if we keep the container closed, then one thing we are keeping constant, that is volume, right? Isn't it?
Yes,
Yes,
sir.
sir. The volume will be constant.
So V is constant and we are increasing the temperature. Then what will happen to the gas? What will happen to the gas? Can you tell me, please?
So can you repeat the question?
Question is, if we keep the container closed, right,
Yes.
then the volume is constant. That means the container is fixed, right? So the
Yes,
volume
sir.
of the gas is fixed. Now, what will happen to the gas if we increase the temperature?
Sir, their
It
particles
will
will
start
move
to condense.
rapidly in every direction inside the container, and
Yes,
it will be very fast.
with high kinetic energy, right? With,
With
Yes,
high
sir.
kinetic energy,
Right.
yeah, if they are moving with
and
high kinetic energy, then what they will do on the container? They will apply more pressure on the container, right?
yes, sir. And if the temperature is high enough, the container might explode also.
Yes, very good, very good. So, what can we deduce? That pressure will increase, right?
Yes, sir.
So, due to the temperature increase, if the volume is constant, then P increases, right? P is more, right? And from where this P is coming? Can you tell me? You know one formula, P equals F by A. Can you remember that formula?
Yes, sir. Force by area.
So force
Yes,
by
sir.
area, that means your container, if it is fixed container, that means your area is same, right? The in
Yes, sir. And
the inner
force
area of
is
the
the
container, it is same. So what is increasing? Force is increasing, right? As
Yes, sir.
as the gas molecules are hitting the container wall with greater force, greater kinetic energy, so we can say the force is increasing. That's why pressure is more. Can we say this one?
Yes, sir.
স্যার বুঝলাম না আরেকবার বুঝান তো
uh, I'm asking
এতটুকু
you.
বুঝলাম স্যার যে এরিয়া একই থাকবে এরিয়া একই আসে
Area is same, but one thing you understood, that they have more kinetic energy, right? The gas molecules,
ইয়েস স্যার
if the
ইয়েস স্যার
temperature is more,
as they're
then
heated
they have more kinetic energy, then they will hit the container wall with greater force, right, than
ইয়েস
before.
স্যার
So the
ইয়েস
force is
স্যার
more, force per unit area is more, isn't it?
ইয়েস স্যার
That's
ইয়েস
why
স্যার
pressure is more.
ও
So we can
ওকে
write here as force is more, right?
Sir, force is directly proportional to pressure.
Yes,
I forgot
because
that.
P equals F by A, so P is directly proportional to F and inversely proportional to area. Here area is fixed, but we are increasing the force. That's why our pressure is more. F more. Okay, as F more. Now you are getting another idea. If the container is open, what will happen?
The gas will
The
escape.
gas
The
will
gas particle will
go
escape.
go away from the container.
Okay, container open. I'm writing here container open. Container open. Then you are saying what? Gas particles will expand, right?
No, sir. Escape.
Escape.
Yes, yes.
Why they are escaping? Because they are expanding, right?
Because it is. Yes, sir.
Because their volume is becoming more. They are going far apart. If they are going more far apart, that means their volume is increasing,
Yes,
isn't
sir.
it? So we can write here volume is more, right?
Yeah.
Isn't it? So if the volume is also increasing with the kinetic energy, that time we are getting the same pressure, right? Here only we are getting the volume more, right? When the pressure is more, if the volume will keep constant, you just remember this thing. Container open. I'm writing here container open. Okay, I am coming to that point again. You just reply with me. So if the container is open, that means you are saying the gas will come out, right?
Yes, sir.
Isn't it? And gas will come out because volume is increasing, isn't it?
Yeah.
Volume is increasing. Then what will be the condition of pressure here? Pressure will increase like before.
No, sir.
No, sir.
Pressure will
No,
decrease.
pressure, pressure will be as usual, or you are saying it's decreased, right? If it is not increasing temperature, if you are only opening the container, that time the pressure will decrease. It is true because the volume is increasing. But if you are increasing the temperature, also it is open, then pressure will remain same uh, like before. I am saying that like before. Uh, but if all the molecules are coming out, then there will be no pressure. Is it clear to you? In the container.
Yes, sir.
Hello? Is it clear, everyone?
Yeah.
Okay.
Yes, sir.
Now we can conclude here. Uh, Here I am writing V is more, right? I'm writing here V is more. V is more. So this one I am having the recording also so that you can get it later. Now we are now going through this learning outcome. Describe the relationship between the motion of molecules and temperature. So this one is done, right? You understood it. Motion of molecules will be more, right? With temperature increase. Is it clear? Hello?
Yes, sir. Yeah, it is
If
clear.
the temperature is low, then molecules will move less, right? Molecular movements will be less. Then that will be less kinetic energy. Now the second point, explain the pressure of a gas in terms of motion of its molecules. So this one is also discussed, right? Isn't it? Hello?
Yes, sir.
We understood that how the pressure is coming from the molecules. It's hitting the container wall and it's applying one force per unit area. That's why we are getting the pressure, isn't it? And if the container is sealed, we are increasing the temperature, then the pressure will be more. So this much is clear, everyone? Hello?
Yes, sir. Yes, sir. Yes. Sir.
Okay, very good. So these all things are, I'm showing you in your book, how it is shown in your book, where you'll get it. You just go through whatever I discussed. It's available also in your book. If you go through here, this one, motion of molecules and temperature. Okay, here you will get. And here we have one experiment by Robert Brown. Eh, In this experiment, he found this one, molecular movement of liquid and molecular movement of gas. In Brownian motion, he got molecular movement of gas and molecular movement of liquid. So how he got it? He kept some first experiment. He kept some gas molecules, that means air particles, and he is mixing up some smoke with the gas particles, that means air particles. He is mixing up some uh, smoke. Smoke particles are little bit bigger, isn't it? And you can observe smoke particles with the microscope. As air particles does not have any color, you are not seeing them, you cannot see their movement. Are you getting me what I am saying?
No, sir.
Hello?
Can you explain it again?
Yeah, I am explaining again. Like this one is a container, and inside it has air particles and smoke particles. Okay, are you clear now?
Yes, sir.
And
Yes, sir.
inside it we are giving light. Ah, very high intensity light we are giving. So when we are seeing with the microscope, we see that smoke particles, they are moving randomly inside this container. Smoke particles are moving randomly inside the container with high speed. So how we see it, or why we see it? Smoke particles, they don't have any movement normally. However, they are moving. Why they are moving? Hello? Hello?
Yeah,
Hello, sir.
because of
Yeah.
the sir, light source, sir, converging light source in the converging lens.
Okay, so the reason is air particles, they are hitting the smoke particles with high speed. Because of their bombardment of the air particles with the, or the heating of the uh, air particles of, heating means colliding. Do you understand? Heating means
Yes, sir.
HIT, heating. That heating means colliding with the smoke particles and letting the smoke particles to move randomly. Is it clear now?
Sir, why the smoke particles will not move, sir,
Yeah,
by their own?
smoke particles, uh, they they are not fluid. They are only particles. Is it clear to
So
you?
they are they
They
are
are like
they
solid,
are a bit
solid. They,
heavy.
they are tiny solids, small
So
solid
time.
particles. They are, yeah, very small, but they are solid. They are not liquid, or they are not fluid. Is it clear to you?
Yes, sir.
You got your answer. Very good. So, but we are seeing that smoke particles, though they are solid, but they are moving randomly. Why? Because of the colliding with the air particles. So from this experiment, we understand the molecular movement of air particles. Is it clear now?
Yes, sir.
This is called Brownian motion. Okay, as Robert Brown
What?
discovered it, that's why it is called Brownian motion. So till this much today, okay?
Sir, can you explain the gas one again? Like Why a smoke particle move? Because
we
of the
have
light.
you just read it, huh, and have the recording. Tomorrow we'll discuss. We have less time. Okay. Thank you. Huh? Thank you so much.
Bye,
Tomorrow we'll
sir.
discuss again.
Assalamu alaikum.
Salam.